Hello guys, welcome back to the channel. Today I'm going to be doing another FE review problem for you. In this case we have a soil mechanics AASHTO soil classification problem. So basically we're given the particle size distribution and Atterberg limits for a soil sample, and we are asked to classify the soil based on the AASHTO classification system. So basically, the first thing that we're going to do when we're given a problem like this is we go to the FE reference manual to find the information we need. The AASHTO classification parameters can be found on page 266 of the FE reference manual. For this video, I am going to pull up the information here on screen so we can walk through the problem a bit easier, and I can show you how to do this. So here we have the information. The problem gives us a particle size distribution and Atterberg limits, and then we have our table to go with it. Now what we do is we start on the left side of the table and we work our way to the right side of the table in order to classify our soil. So the first thing that we see is group classification and sieve analysis percent passing. So the first one that it says right here is percent passing for the number 10 sieve. We don't have information for that, but we do have information for the percent passing the number 40 sieve. In our case, its percent passing is 53%. So when we make our way to the right side of the table, we hit this first number, which is percent passing less than 30. Ours is 53, so we know it can't be this soil. We keep going to the right. We see percent passing less than or equal to 50. That can't be our soil either because our soil is 53%, like I said, for the number 40 sieve. So now we hit greater than or equal to 51%, starting with this soil here and every soil to the right. We know that one of those soils is our soil because this is greater than or equal to 51, and we have 53% for our soil. So far we can eliminate A from the multiple choice. So we know that it can't be that one because it would need to have a percent passing less than or equal to 30, and we have 53%. So we can eliminate option A. So now we take a look at our next parameter, which would be the percent passing the number 200 sieve. Ours is going to be 39%. We already know that these two soils, these first two, are not the soil that we have, so we'll just start here. And 39% is not less than or equal to 10, so it's not this one either. And then here we have less than or equal to 35%, so it's not this one, it's not this one, it's not this one, and it's not this one. So we can completely rule out the A2 group of soils, and one of those was actually in our multiple choice. It was A2-5, so we can actually cross that one out too. Now we know that it needs to be one of these because these options over here are the only ones that have percent passing for the number 200 sieve greater than or equal to 36%. For our soil we have 39%, so it has to be one of these four, right? Our options that are left are A5 and A75. So it's either this one or it's this one. So now the way that we proceed is we go to this part of the table right here and we align the other information we were given with these parameters that I am going to show you. So the first one was the liquid limit. We were told that for this soil sample we have a liquid limit of 42. So looking at A5 and A75, which are our two remaining choices, we have a liquid limit for those being greater than or equal to 41. So as you can see, it could be either one of those at this point because our liquid limit is 42, and 42 is in line with both of these parameters here, greater than or equal to 41. So the next parameter that we can look at to further classify our soil is plasticity index. we were not directly given the plasticity index, but we can solve for it with what we were given. Plasticity index is equal to liquid limit minus plastic limit, and we were given both of those. So our plasticity index is going to be equal to our liquid limit of 42 minus our plastic limit of 33, and that is going to give us a plasticity index of 9. So now that we know our plasticity index, we can take a look at our remaining choices of A5 and A75, and we see that the only one that can be in line with our soil is A5, because this one has plasticity index less than or equal to 10, and this one has plasticity index greater than or equal to 11, so it can't be this one. Therefore, after all of the classification is complete, we know that the multiple choice answer is C. So basically, that is how you conduct a soil classification using the AASHTO system on the FE exam. Like I said, this table can be found on page 266. So you just pull up the table and then you work your way through the table using the data that you were given. Also, don't forget that plasticity index is equal to liquid limit minus plastic limit. And I highly suggest that you follow the process we did in this video, which is that we crossed out the soils from the multiple choice that we knew for sure were not our answer. Because once you narrow it down to a couple of soils, it's easier to determine what you're really looking for, and it makes the problem solving process more efficient. And the FE exam is all about solving these problems efficiently and quickly. If you would like to see more problems like this in the future, make sure to subscribe to the channel and leave a like. Also, leave any feedback in the comments on what you would like to see me cover in the future. Once again, thank you for your time, and I will see you in the next video.